GCSE Physics boosters, generators. In the last video we talked about the generator effect. I'm just going to talk about a couple of different types of generators. This is what happens in a power station. Something makes the generator turn around, and it's usually a thing called a turbine. It might be a steam turbine, like in this nuclear power station. It might be a water turbine, as in a dam, or it might be a wind turbine. But the point is that something is making the generator turn around, and then you've got the generator effect producing electricity. Something that's missing off this diagram are any transformers. I'm going to talk about them next. And yet another good animation that I've pinched. Now, there are two types of generator that we need to know. And basically, they've both got coils rotating in magnetic fields. But this type of generator is called an alternator. And it produces an AC voltage. I've done a video on AC already. If you look at this, that's what an AC voltage looks like. Positive, negative, positive, negative. So an alternator produces an AC voltage. The difference between the two types is the way that the coil is connected to the output. And in an alternator, you've got things called slip rings, and you don't need to know. Okay, but slip rings and brushes, it's a sliding contact. You need to remember alternating current AC and be able to sketch that diagram. The other type of generator is called a dynamo, and a dynamo produces a DC voltage. It's not a steady DC voltage at the moment, but it's DC. It's all positive. It's all one direction. Okay, so alternator AC, dynamo DC. The way that it does it is it uses a thing called a commutator. Again, you don't need to know, but on that animation there's a commutator, and a lot of these things have lots and lots of coils. There's a photograph of a commutator, a typical commutator. It is actually this thing here. That's the commutator there. There's all the different coils. Okay, and then the brushes would rub up against the commutator, and that's your connection. Something else we need to know is how a moving coil microphone works. There are different types of microphone, but this type of microphone has got a coil in it, like a copper coil, which can move. Now, what makes it move is sound waves. So sound waves make the diaphragm vibrate, and that makes the coil vibrate. The coil is in a magnetic field, and then the generator effect produces an alternating signal, an audio signal, yeah, alternating voltage. Okay, so if I took this SM58 to bits, I would find something like a magnet and a coil. Okay, it's the opposite of what a loudspeaker does. If you remember, a loudspeaker uses the motor effect to convert an electrical signal into pressure variations in the air. I don't know why they don't just say sound, but there you go. A microphone uses the generator effect to convert pressure variations in the air into an electrical signal.